Hi students, Namaskaram. Now we are discussing a practical problem in the chapter ANOVA table, analysis of variance. The question: a special fertilizer was experimented on 4 fields A, B, C and D. In each field, 4 beds were prepared and fertilizer was used. The yields of beds of fields are given below. A, B, C, D. A 8, 12, 1, 3. B 9, 4, 7, 1. C 3, 8, 2, 5. D 3, 7, 8, 3. Find out whether the difference between mean yields in the fields is significant or not. This is the question. We have to analyze the mean yield of fields, and yield of fields are given in column in the question. Therefore, there is no need of rearrangement of the table. ഈ ക്വസ്റ്റ്യനിൽ നമ്മോട് ചോദിച്ചിരിക്കുന്നത് 4 ഫീൽഡുകളുടെ ആവറേജ് yield ഒരേപോലെയാണോ, സിഗ്നിഫിക്കന്റ് ഡിഫറൻസ് ഉണ്ടോ? അനോവ ടേബിൾ ഇത് വൺ വേ ആണ്. വൺ വേ അനോവ ടേബിൾ ചെയ്യണമെങ്കിൽ സാമ്പിൾസ് കോളത്തിലാണ് നമ്മൾ എഴുതേണ്ടത്. ഇവിടെ 4 സാമ്പിൾസ് ആണുള്ളത്. ഫീൽഡ് എ, ഫീൽഡ് ബി, ഫീൽഡ് സി ആൻഡ് ഫീൽഡ് ഡി. ക്വസ്റ്റ്യനിൽ ഈ സാമ്പിൾസ് കോളം ആയിട്ടാണ് തന്നിരിക്കുന്നത്. അതുകൊണ്ട് ഈ ക്വസ്റ്റ്യനിൽ ഇനി പ്രത്യേകിച്ച് റീഅറേഞ്ച്മെന്റിന്റെ ആവശ്യമില്ല. ഈ തന്നിരിക്കുന്ന ഇതേ ടേബിൾ തന്നെ നമുക്ക് ആൻസറിന് വേണ്ടി ഉപയോഗിക്കാവുന്നതാണ്. ഓക്കെ, വി ആർ എൻറ്ററിംഗ് ടു സൊല്യൂഷൻ. First, get the total of each columns, each sample. Each column represent sample. Get the total of each column. We get total of first column 24, second column 21, third column 18 and fourth column 21. Then find grand total. The total of all items is equal to 24 plus 21 plus 18 plus 20, 84. Add the column totals, we get grand total. It is represented by T. T is equal to 84. For the calculation of ANOVA table, first of all we have to compute the correction factor. Correction factor is equal to T square divided by N. N means number of items in the table. We have 4 into 4 table, 16 items. That is equal to T. 84 square divided by 16. We get 441. It is the correction factor, 441. Then find sum of squares of all items, SST. Sum of squares of all items. We have to square each and every items in the table, get its total and deduct the correction factor from the total. നമുക്ക് ക്വസ്റ്റ്യൻ തന്നിരിക്കുന്ന എല്ലാ ഐറ്റംസിന്റെയും സ്ക്വയർ കണ്ടുപിടിക്കുക, ആ സ്ക്വയർ സമപ്പ് ചെയ്യുക, അതിൽ നിന്നും കറക്ഷൻ ഫാക്ടർ കുറയ്ക്കുക. 8 സ്ക്വയർ പ്ലസ് 9 സ്ക്വയർ പ്ലസ് 3 സ്ക്വയർ പ്ലസ് 3 സ്ക്വയർ പ്ലസ് 12 സ്ക്വയർ പ്ലസ് 4 square plus 8 square plus 7 square plus 1 square plus 7 square plus 2 square plus 8 square plus 3 square plus 1 square plus 5 square plus 2 square minus correction factor 441. We get SST 157. 157. SST. Sum of squares of all items. Then find sum of squares between columns, between samples, SSC. Sum of squares between samples or between columns, SSC. It is equal to first column total square divided by first column number plus second column total square divided by second column number plus third column total square divided by third column number plus fourth column total square divided by fourth column number minus correction factor. ഓരോ സാമ്പിളിന്റെയും ടോട്ടൽ സ്ക്വയർ ഡിവൈഡ് ബൈ ആ സാമ്പിളിന്റെ എണ്ണം. ഇവിടെ 4 സാമ്പിൾസ് ആണുള്ളത്. ഫസ്റ്റ് കോളം represents first sample. First column total square divided by first column number plus second column represents second sample. Second column total square divided by second column number plus ഇതുപോലെ third column, fourth column minus correction factor. That is 24 square divided by 4 plus 21 square divided by 4 plus 18 square divided by 4 plus 21 square divided by 4 minus 441. We get SSC 4.5. Then compute SSC, sum of squares within columns, SSE. It is equal to the difference between SST and SSC. That is SST minus SSC. We have SST 157 minus SSC 4.5. We get 152.5 SSE. Then compute mean square. Mean square between columns, MSC. Mean square between columns is equal to SSC divided by number of columns minus 1. The MSC depends upon SSC. MSC is equal to SSC divided by number of columns minus 1. We have 4 columns. That is equal to SSC 4.5 divided by 4 minus 1, 3 is equal to 1.5. MSC is equal to 1.5. Then get MSE. MSE is equal to SSC divided by number of items minus number of columns. MSE is equal to SSE divided by number of items minus number of columns. SSE 152.5 divided by number of items 16 minus number of columns 4, 12. We get MSC is 12.7. Then we have to construct null hypothesis. Null hypothesis is there is no significant difference between mean yield of 4 fields. X bar 1 is equal to X bar 2 is equal to X bar 3 is equal to X bar 4. 4 സാമ്പിൾസിന്റെയും മീനിൽ ആവറേജിൽ ശരാശരിയിൽ വ്യതിയാനങ്ങളില്ല. There is no significant difference between the average yield of 4 samples. It is the null hypothesis. Alternative hypothesis, there is significant difference between the average of 4 fields. Now we have null hypothesis and alternative hypothesis. For computing test statistic, we have 2 proportions. MSE 1.5, it is a variance. MSE 12.7, it is another variance. For the computation of F ratio, we have 2 variances, MSE 1.5, MSE 12.7. And test statistic F is equal to larger variance divided by smaller variance. Here, larger variance is 12.7. Smaller variance is 1.5. Therefore, F is equal to 12.7 divided by 1.5. That is equal to 8.47. It is the test statistic. That is computed value of F is 8.47. Then find table value. Level of significance 0.05. It is F test. We have to find degree of freedom. For computing F test, there are 2 degrees of freedom, V1 and V2. V1 is the denominator of larger variance. നമ്മൾ 2 വേരിയൻസുകൾ കണ്ടുപിടിച്ചിട്ടുണ്ട്. അതിൽ വലിയ വേരിയൻസിന്റെ ഡിനോമിനേറ്റർ ആണ് V1. വലിയ വേരിയൻസ് MSc ആയിരുന്നു 12.7. 12.7 കണ്ടുപിടിച്ചിരിക്കുന്നത് 152.5 divided by 12. ഇവിടെ ഡിനോമിനേറ്റർ 12 ആണ്. 12 ആണ് നമ്മുടെ V1. Then V2. V2 is the denominator of smaller variance. Smaller variance. It is MSc. Smaller variance is MSc. MSc is equal to 4.5 divided by 3. 3 is the denominator. Therefore, V2 is the 3. Now we have V1 12, V2 3. It is the degree of freedom. Level of significance 0.05. Find table value. It is 8.74. Then compare table value with the computed value. Then we can say the computed value is less than table value, and therefore we accept the H0. We accept the null hypothesis. It means there is no significant difference between mean yield of the 4 fields. 4 ഫീൽഡുകളുടെ ആവറേജ് yield കാര്യമായ വ്യതിയാനങ്ങൾ ഇല്ല. This is our answer, but this answer is to be attached with a ANOVA table. Question അവസാനം നാം ANOVA table വരയ്ക്കണം. This is the ANOVA table. Source of variation, sum of squares, degree of freedom, mean squares, F ratio. For rows, between columns, within columns, sum of squares of values. First, source of variation between columns. It is SSE 4.5. Then within column, it is SSE 152.5. Then sum of squares of values SST 157. Degree of freedom. For SSE, it is number of columns minus 1, 3. Mean squares SSE divided by 3. 4.5 divided by 3. It is MSc 1.5. Then SSE 152.5. Degree of freedom. Number of items minus number of columns. 16 minus 4, 12. Compute mean square MSE. It is SSE divided by degree of freedom. 152.5 divided by 12. MSc 12.7. Find F ratio. It is the larger variance divided by smaller variance. 12.7 divided by 1.5. We get 8.47. It is the ANOVA table. So thank you.